I'd like to take a few minutes and talk about the kind of materials we might use in this punch facade, the cladding systems, not the glazing system specifically. So I'll start out with where I'm kind of getting a lot of my information. This is hyperlinked. You may be interested if you want to really dig into the technical details. These are the kind of things that I try to watch and gather as much information to kind of deliver to coursework. So kind of this was a detailing of high performance facades, cladding decisions, and sealing strategies. It might appear to be a real snoozer to you, but it does contain a lot of very interesting content, at least from a technical standpoint. And so I'm going to cover, three or four different kinds of facade materials. I guess kind of to stimulate thinking, thinking about things like carbon footprint, embodied carbon. And we'll start out with this idea of veneered stone and marble because it's kind of a high-tech material, a high-tech and low-tech kind of mixed together. So obviously we are coring, these are shots of coring marble and stone. Um, and the idea of material extraction, this has an environmental impact that you may not immediately have with the idea of quarrying and the intended damage to the environment. How significant it is up for kind of analysis, but just some kind of visuals about that idea of material extraction. And so the tech part of that is that they make these marble and stone sheets very thin, so thin that they don't have enough structural integrity to them on their own to become a cladding system. But they introduce this idea of a honeycomb. So here we have a little hard to see, but this is a honeycomb material that's stretched out, very lightweight aluminum honeycomb material. Um, and so you're looking on the left-hand side here of the honeycomb before it's stretched out, so it's all compacted. Then they stretch it out onto a table, and then they put a laminating sheet on it. You can kind of see the texture of the honeycomb core through that plastic sheet that's on the top. I really should have a better image of honeycomb. I'll try to add that to the slide pack before I make the formal presentation of this lecture in class. But anyway, they take that honeycomb, they put these epoxy impregnated sheets upon them in order to create bonding to the stone system. And then this is kind of the example of this now very thin stone attached to what looks like conventional steel framing, creating these really kind of wonderful, in this case, this is Indiana limestone, large panels, 8 foot by 8 foot, and then articulated into these nice prefabricated components with all kinds of architectural detailing on them. And the system allows for all kinds of creation. So here we have a nice example and a mock-up of what can be done with stonework in very thin materials. Now, most of the things I'm going to talk about are very thin. The idea here is to reduce the weight that is hung on the outside of the building, reduce the amount of material that is used in order to create the aesthetic that we desire. So in this case, from the viewpoint of the person on the street looking at the facade looks to be like a massive stone element, and while in fact it's a very lightweight stone structure with amazing amounts of durability to them. And here's a nice detail of another mock-up of that assembly. You notice the joints are seamless, so it looks like it's a monolithic type of surface. So they really have a high degree of control over these materials. And this is actually fitting into that idea of that punched opening that we're discussing. Another material, surprising material, are porcelain tiles. So here we have now um, a, um, a clay material made into a slurry and then dried and fired in order to create a high performance ceramic material. Um, the advancements in the ability to produce these at high quantity and in large sizes is quite amazing. So now we have panels that are in the, it appears to me like that looks like at least a 4 foot by 3 foot panel of a ceramic material. It's very thin, and if you look on the left-hand side here, you can see there's even a thin little slit in each one of those tiles that allows for this attachment clip. And you'll notice that this is following a rain screen concept to it. We have open joints, we have a ventilated cavity, we have the insulation, all of the things that are what we commonly understand when we're thinking about rain screen applications. So you can create nice panelized systems. And I wouldn't leave it to thinking about this as just a monolithic surface. Obviously, we can create punched openings, as you see over my head here, and utilize these panel systems too to create much more planar, kind of modern surfaces with these kind of materials. Obviously, metal panels. This is a company called Dry Design. They make a relatively lightweight, thin piece of metal panel that they form into a box, a thin little pan, and all kinds of decorative shapes can go along with this. And as you'll see, same thing in the illustration on the left. These follow the same concepts of rain screen construction. So we have ventilation channels, we have insulation on the exterior of the construction of our wall, etc. And I'm showing you all of these materials because many times these materials can actually look and mimic the other material to some degree. Metal panels can be painted with surfaces that can look stone-like. Not that we want to substitute those, but we can create panelized systems with virtually many different kinds of materials. And it's really up to us to actually look at, what's the aesthetic we're looking for, but also what's the carbon footprint? What's the embodied carbon that's in the material that we're going to be using on that facade? And we have lots of choices to make when we're choosing that. And this is one that I don't see advertised a lot. I'm not sure how active they are with it, but a few years back, this used to be a very popular type of cladding system for buildings because of its because its abilities to be flat and planar, to have many color variations, to be easily fabricated in the field. The idea is it's a high pressure laminate bonded to some sort of substrate to create an exterior. Typically you think about high pressure laminates as Formica countertops, but this is a similar material now adapted for exterior use. It seems to be very popular. I'm not sure if it still sees that kind of popularity, but once again, another material in following basically the same kinds of ideas about application techniques and aesthetics. This is actually Boston Valley terracotta on the left-hand side here. This is the Betchler Museum. This is actually one of the first complex projects that Boston Valley got involved with. I can remember actually the president kind of mentioning to me that he was glad that I encouraged him to kind of explore this project. They were a little bit timid because it was an advanced project. And even though I really knew nothing about that was going to help them along, I really encouraged them to explore it. And they did, and they accomplished it. And it really changed a lot of their projects going forward, what they learned, their ability to kind of venture out. So this was one of the first projects with terracotta that had, and I'm not showing all the features of this building, but I'm using this just as an example to introduce that idea of terracotta. I think starkly, you can see now that these panel systems are much thicker. They have the potential of possibly having more issues of embodied carbon. They may not be as energy efficient as some of the other materials we've seen. On the other side of it, you can create a multitude of different shapes by the way you fabricate them, and we'll discuss that a little bit later on.